So the next example that we're going to go through is 6 and -7. And basically what we're doing in this example is we're trying to write the equation of the polynomial. Now this is given our zeros. And if you guys remember, when we were solving, when you guys had your last test, when you solved, you got x equals something else, right? That's what the answers are supposed to be. X equals, that's where the graph crossed the x-axis. So the first step you guys are going to do is set both of these equal to x. OK? These are your answers. These are your zeros, your solutions. So we set them equal to x. Because basically, these zeros, that's where the graph crossed the x-axis. If you guys remember, when you guys had one, those are the values where the graph crossed, right? So that's what x equals. That's, x equals at those values. Now, but how do we come up to them? Well, we got these because we set them equal to 0. So I have x minus 6 equals 0, and x, oh, I'm sorry, let's show how to set them equal to 0. So then we need to set them equal to 0, so we subtract a 6 on both sides, add a 7 on both sides. Therefore, I have x minus 6 equals 0, and x plus 7 equals 0. Does everybody see what I did? I basically set them equal to 0. And the reason why we set them equal to 0 is because we are applying the zero product property. All right? And if you remember, when we had the zero product property, we had two factors multiplied by each other equal to 0. And when you have two factors multiplied by each other equal to 0, Noah, what you did was you set them both equal to 0. Do you guys remember that? Do you guys remember having like a problem like x plus 2 times x plus 3 equals 0? Then the next step is to set them equal to 0, right? Right? You set them both equal to 0. That's how we solved. Well, here, this is like the step before that. So now, to rewrite it as the polynomial, we're going to multiply both of these factors times each other equal to 0. Basically, ladies and gentlemen, if you think of yourself, if you look upside down and you solve this problem from here to here, it's basically doing the exact opposite of what we've done before. I've showed you guys how to take an equation and solve for the zeros. Basically, now what we're doing is finding the zeros and writing the equation. So you're pretty much working your way back up. Molly, this is going to be your first official warning. You need to put that away. So now, when you guys look at this, we're not solving for the 0. We already have the 0. So we're trying to multiply this so we can get the equation. So now we have to multiply a binomial times a binomial, not to equal 0, but to equal an equation y, right? Remember we always started equations like with y equals this, and then we set the y equal to 0? So now we're pretty much going back. We're taking the 0 and replacing it with a y, because that's what we're trying to find. We're trying to find the equation. So now we have to multiply this. Now, to multiply this, I'm going to go back to using the box method, because this is going to become very helpful for you guys in the next problem. So basically, when I like to multiply binomials, what I like to do is take one and put it up top, and take the other and put it on the side. Now, basically, all I have to do is find the area of each of these boxes. X times x is x squared. X times -6 is -6x. X times 7 is 7x. And 7 times -6 is -42. And the reason why I like the box method the best is because now you guys can see that these diagonal terms are like terms. They both have an x to the first power. So we can combine them. So my final answer is x squared. 7x minus 6x is just x, positive x, minus 42 equals y. Now, ladies and gentlemen, I have given you the zeros, and we have now written the equation, where it's y equals x squared plus x minus 42. Do you guys remember on your test or in your homework